Hello everyone, welcome back to this lecture. I hope all are well. In previous lecture, I discussed about the what is feature engineering and data preprocessing. Let's recap in few minutes. We understood in previous lecture what is data preprocessing. Why do we need to do a data preprocessing as well as feature engineering? As we know, machine learning rely on the high quality data so that we get a performance that is outperforming the model that trained on the poor data set. Raw data may be incomplete, inconsistent, and noisy, outliers, and some values are missing that make a model inefficient if you train on the raw data set. That's why we need to pre-process and feature engineering the data set so that we get a higher performance of a model. Data processing having a process of cleaning, transforming, and organizing the data into a structural format. So there are key steps we need to keep in mind when we study the data processing. First is handling missing values, outliers, normalization scaling, encoding categorical data, and data transformation and feature selection. So both these steps in a data preprocessing are crucial if you are building a high performance of a model. And it will improve the data quality and it substantially improve your model accuracy. If I talk about the feature engineering, it will create the new feature and modifying the existing feature to improve the model performance. So there are several techniques: feature extraction, feature transformation using log transformation, feature generation or creation of new feature based on the existing features, and selecting the features that are most relevant our data set to have a higher and correct prediction. So, so it helps in improving the model accuracy and performance and reducing the overfitting and enhance the interpretability of ML model. Uh, in previous lecture, I explained this concept through the examples and it having a none values, none missing values are there and categorical data and I explain features, label targets and so on. In this lecture, I will move this idea of previous lecture and I will cover in depth about the raw data and what are the missing values and how to handle them. So let's see. So uh, so raw data. Let me take a pen. Okay, raw data collected from various sources that is incomplete, inconsistent, and noisy. The data you collect from a source that may be incomplete, inconsistent, and noisy, and having some missing values that negatively impact your performance of the machine learning models. That's why we need to process the data set before feeding the into the model. So data preprocessing is crucial step to clean, transform, and prepare the data for achieving a higher model accuracy. Okay, and so let's start with the missing value. If your data having a missing values, so how to handle them? First, you need to know what is the missing value. Let's start. So missing value occur when some data point are not recorded. Means the data points are not recorded. Let's start. What are the causes of missing data? Data entry error. If human enter a data manually, it will be manual mistake or human error mistakes. Technical failure. When sensor are collecting a data, it if some change in the structure, it lead to a having some missing values. And privacy concerns. User are not providing a data, so we need to leave that column or leave that data point. And incomplete dataset collection. It means dataset become a more corrupt that lead to a missing. So these are the common and major causes of missing data. The most one is major one is a data entry error, like human enter a wrong or enter a miss the uh, entry in the rows. And second is a sensor breakdown. When those sensors are collecting a data, it malfunction, it is not properly working out, and power cut. It lead to a problem in and it lead to a problem in collecting a data. That's why it lead to a missing value in a data set. So let's understand how value look like. So we have a student column that have A, B, C, D, and their math scores, science scores, and English scores. Okay, these are the their this are the training examples, and so these are the features. Okay, so in a math score, you have a numerical value 85, 78, 92, but here is a NaN. It means not a number, not a number. Here, this is a missing value. So this is a missing value. So you there discuss there are a lot of reason we have a data set that having a missing values. So here is a NaN. So that need to be deal and to be corrected then before feeding it into the machine learning models. Here in science score we have a 90 NaN. Here is the same missing value we encounter 95, 88. In a English score column 88, 82. Here we get a missing value in 80. So these are the missing values this that need to be this we need to be resolved. This need to be removed or use some other algorithm or statistical techniques that we use to put a some value where the missing value are present. We will see this thing in a later part of the lecture. So missing value are those values that are user or human error, a sensor malfunction, and any other reason data entry is not done. So outlier are the extreme values. Outlier are the extreme values in the dataset that significantly differ from the rest. It means the value you have a dataset, and suppose you have a data set having a income column. Income column are salary are the in a range of 10k, 10,000, and someone 10 to 20,000, and some person having salary for in crore. So that is outlier that need to be corrected. If you before if you don't treat them, so it will lead to a biased in the model. Model fail to recognize the pattern which are present in the data set. Okay. So this value can cause a skew statistical analysis and impact the machine learning models. Okay, the value differ extremely from the rest of the data set data point. So what are the reasons of having a outlier data set? First or major reason is human error. When people or human enter a data in a database, and sensor malfunction is a technical problems, and genuine extreme variation, person may have a higher salary. Okay, so let's see the example. So in a monthly income, you see this is a sub part of the data set. I take a only monthly income feature that have a some values, but you will see the values are in the 4 digit. But here you encounter a 6 digit, six figure number. So you see this is the outlier because it is far from the other values. So outlier affect the mean of that column and feature as well as affect the machine learning model. So we need to treat the outlier so that we have a clean data set without outlier. Then we can feed into the machine learning model to have a higher performance of a model. And noisy data. So in a new noisy data are those data and contains a errors, randoms, variables, or irrelevant information. The data which have errors, like you enter a ram @gmail.com. Okay, so some error occur like has came, so it is a noisy data, it is difficult to interpret. And random variables like random variations, there is no pattern are there in data set, irrelevant information are provided that confusing the machine learning model. So this is the reason your model having a lower performance. Okay, so let's understand what are the causes of noise data. First is measurement error, environmental error हो गया, GPS sensor, technical error I say, and inconsistent data recording method. Let's see the example. So in this example, you will see customer column having A or B, two entry. Here noisy data. Here you will see the special character added. This is the confusing the machine learning models, which lead to a lower performance of the model. But right data is a good product, but here special character came that make the data unsuitable for the machine learning model. Similarly, for this data, we have a at the rate has or correct value is a bad service. So this noise data come due to the human error, technical error. So they have to be corrected before feeding data into the machine learning model. So let's see the next issue in raw data is inconsistent data. Here you will see the data set having a conflicting and duplicate values. Conflicting and duplicate values or incorrectly formatted values means if you're having a data set, one of the feature is a date, but in a date column you have a number of date format. You following the multiple date format, you don't have a consistent one date format, that confusing the machine learning model, which produce a lower performance of a algorithm. So that's why we need to ensure the consistency in the data set if you are looking for a higher performance of a model. So what are the reasons for a inconsistent data? Like incorrectly labeled data. Someone add the male or female if you have a gender column, but someone add a writing through the M or F. If you have a both this information in your data set, it will lead to a problem. You should have a male female, yeah, having a M and F only. Okay, you don't have a both of them. If you have both of them, it will lead to a inconsistent in your data set. Data enter from multiple source. Every source has its own principles and ethical principles that follow, and if you collect data from multiple sources, there are higher chance that, there is an inconsistency in the data set. So before feeding the data into a machine learning model, we have to pre-process them so that our data set having a consistency. And you will find some duplicate entry that need to be removed. Okay, due to improper data merging. If you are merging a data set, so you can get a duplicate entries, so that need to be removed. So let's see the example of inconsistent data. As I explained, in a date format, date of birth, we have a name column, date of birth column, and city column. These are features. These are training examples. We have three examples: John, Elias, Mark. In the John row, we have a date and their city. Then you will see in a date of birth column. Here is a this format. This is a DD, date, and month, and YY. This format, that is good. But here is a slash. Here is a hyphen. There is a slash, but here is a format change. Either is a YY came. Here is a day came. Here is a month came. So you will see there is a lot of inconsistency that occur through the when you are collecting a data set from multiple sources. Okay, so first we need to correct them. We need to make the data set consistent, following the single and unique format that help in achieving a higher accuracy of models. So we have seen a lot of issues in our raw data set. Inconsistent data first, second is a missing values we have, and third is a outlier problem, and fourth one is a noise data, having an error, having a special character that need to be corrected or dealt with a suitable and appropriate method before feeding the data into the machine learning model. So one by one, I will explain how each problem can be resolved through a strategic method. So in this lecture, no, I will discuss only handling a missing data. In subsequent lecture and upcoming lecture, I will discuss the other problems and how can we resolve them. So let us understand the how to handle the missing data. You have a raw data set and that contain a missing values. How can we deal them? There are two primary approach present in a market, and if you read any book, so you will find two major approach. First is a deletion method, and second is the imputation method. Okay, so first understand deletion method. Here what we are doing, we are trying to removing the missing data. Means we are trying to removing the missing data. If you have any missing values in our data set, we are trying to removing them that get rid of the data set that have a missing values. So in this deletion method, we have a two type of removal. First one is a removing the row with missing data. It only first see, okay, it only a few row contain a missing values. They can be removed to avoid the introducing a bias in the model. Suppose you have a data set like students having a 4 training example CD and their score, science score and English score. You have a none. This is a previous example, and this is a none. And so what we do in a deletion method, where we are trying to removing the rows, like I remove this row and this row as well and this row as well. I will do BCD row. After removing the row, we will have only this data set. So we are trying to removing the rows, but this method will only applicable when you have a large number of training examples. Large number of training examples you have. If you don't have, so you cannot remove it. So you need to go for imputation method. I will discuss in later part of the lecture. So that method is effective only if you have a large number of training examples, because you are deleting the data. So after deletion of data, you have only one training examples having these values. Okay. Suppose you have a data set that are having a large missing values in a columns. Removing a columns with the too many missing values. Like you have a cholesterol level. Uh, and first I move. Okay. So here you have a patient ID, and here three training examples and their age and their blood pressure and cholesterol level. The cholesterol level feature having a missing values means NaN, not a number. So if you train the model with this data set without any pre-processing, so it will lead to a lower performance of model or fail to uh, build a understand the pattern that are present in data set. So if it is in a rows, like if it is none here, so you can remove the whole rows. But if in this case we have a missing values in the cholesterol level, so we need to remove the this feature. We will remove this feature. We will only have this patient ID, age, and blood pressure feature. We will remove this cholesterol level feature completely. But it will also have a drawbacks, because if you remove the cholesterol level feature, it might have a certain values and certain information that help in providing a higher prediction, higher accuracy of a model. So it will lead to a lower performance if you remove the cholesterol level. So we need to be very smart enough to know which feature we need to remove. That you should know which like cholesterol level that impact the our variable or not. If impact higher, so we need to keep it. If it impact is lesser, so we can remove it. So we need to be think based on the data set we have. There is no thumb rule here. We need to know about the how feature are affecting the target variable. Okay. So first method is a deletion method. We are removing the rows. If you have a missing value in rows, if you have a rows in a in a column or in a feature, so you need to remove completely the feature. But at the same time, you need to know you are removing the whole feature. You might lose the information that can have a importance in a target variable. So let us understand the second and most favorite method that are used uh, in a machine learning, because first method may not work because you may not have a large amount of training examples, or you can remove the no rows as well as columns. You cannot do it. But what we do, whatever data we have and missing values, we try to impute them. We are filling the values. So these several methods are here. I will explain and I will discuss here one by one. So imputation method is different from the deletion method. Deletion method are removing the data set, rows or columns, but here imputation method filling the missing values. They are not removing the rows or columns. Okay, training examples or features. So there are three types of imputation: mean imputation, median imputation, and mode imputation. These are a central tendency of the measure in a statistics. If you have read about the, so in a mean, you are trying to replacing the missing values with the average values. I will take an example. Let's understand first theory part. We are replacing the missing values. Whatever missing value we have, we are trying to replacing with the average values. And in median imputation, we are trying to replacing the missing value with the median value, middle values. In mode value, we are replacing the missing value with the most occurrence values. Okay, so that is more suitable for the categorical data. Let's see some example here. So you have a data set where we have three feature: student, math score, and science score. We have a three training example A, B, C. Okay, this row, and this row. So here in math score, in a student ABC, there is no none, that is okay. And in math score, is a number, this is a number, this is a number, okay, that is also okay. In science score, 90 is a number, okay, 95 is a number, but is a NaN, not a number. So we need to do some operation here. We cannot remove, okay, because we have a less data. So we need to impute them. We have to fill the value with some method, mean, median, mode. So mode is applicable for the categorical data, but we can use the mean and median. Generally we use the mean. So in a science score, whatever data we have in this column, whatever data we have this in this column, we will try to first take out the mean. Whatever mean came, we will try to fill them, replacing the none value with the 92.5, that is a mean value for that feature. Similarly we can do for the median. First median, we have to find out the median value or median value in a data set in a column, then we will fill them, okay. And if I talk about the categorical, let's take example, more example. If I enter here gender, I write here, here is a male, female, okay, and here is a male. Here suppose we have a 4 data here, है ना? So I will write here 40, okay, 96. So I have a none value here. So here we will not use the mean and median because it is a categorical data. We have a categories. So we need to use the mode that is dependent on the occurrence. Like in a male, if I count the occurrence of male is a 2 times, 1 and 2, but female is 1 time. So we will fill the value with the most occurrence. Here value will be male, okay. So let's move to the other method, like k nearest neighbor imputation method. In this method we are trying to using the similar data point to predict missing values. Like if I explain in a mathematical, suppose we have a this point and this point, this data point, and we have a some data point here, but it is a missing values here. So we are trying to use this data point and this data point to find out the missing value for that data point. Think like that, this data point nothing but the vector, this is also a vector. So using the similar data point that having a similar features to predict missing values, that is more accurate one, but it is a computationally expensive. So you need to know which that data point that having a missing value, how they are related with the other data points. Then you find, then after that you will find out the missing values. So that's why it is a computationally expensive. And third is a regression imputation. In this we are trying to predict the missing value using a regression model trained on the other variable. I take example, suppose I have a house price and having a 12, this is a random value, 14, I have a none, okay. And I have a some other value as well. This is the target variable, this is a target, and I have a two more feature, like condition or condition and location and number of bedrooms and many feature we have. but there is no missing value in that feature, but we have a only missing value in this house price. So what we do, first we will remove this row, removing this row and training the model that does not have a none value, that does not have a missing value. We train the model, we apply the regression model that I will discuss in a subsequent lecture. So we train the model. After training, we will use this feature to predict the that none value. So that leverage the power of the regression model, regression analysis, that is called linear regression. We will use to using the data point that does not have a none value and train the model. After training model, we will use the trained model to using this feature to predict the this none value or missing value. This is also computationally expensive because you can have a none value in that feature also, and it is useful when missing value correlate with other features. So in this lecture, I discuss about the what is missing values and what is the inconsistent data, how it look like, and what are the outliers and what is noisy data. I discuss in depth with the examples, and after that I discuss how to handle the missing values. They are the two primary method. First is the deletion of the rows, deletion of the missing values. If you have a missing values in a row, so you delete the row. If you have missing value in the column, to remove the columns. But that strategy is not always good because we have a data set in a large number, so it will lead to a problem. So it can be solved through the second method, that is the imputation method, that will not remove the missing value, but that will fill the value through the some technique like mean imputation, median imputation, and mode imputation. And and there are other methods that can be used to filling the values like k nearest neighbor method, that will use the similar features of a data set that will help you to predict the missing value, but that is a computationally expensive. And third one is a regression imputation that will leverage the power of the linear regression model, that will train the model having a features and a target variables, training the model. After training the model, we use the trained model to predict the values. But this is not also a easy method because our data set are not as a ideal data that I used here. So we generally use the imputation method that are rely on the mean, median, and mode. What is for the categorical data. And thank you so much, everyone. I hope you you understand this lecture. And if you have not understood this lecture and any concept, yeah, please leave them in a comment section. I'm happy to resolve them. See you in next lecture.